Hello friends, this is the next in my series about this beautiful Marantz 7.1 channel receiver, model SR7300OSE. This is an AV receiver from about the year 2000. In this episode I'm going to be taking the lid off of it, and one thing I immediately noticed when I started to do that was that the screws appear to be copper. So that sounds like an attention to detail and a deluxe feature that you might expect in a premium unit like this, although I've never seen it before on any other AV receiver. So that's pretty cool. I'll take the screws off real quick and then we'll look inside. I've taken out the side screws, which is 4 large screws on each side, and almost all of the back screws. There's 3 across the back, and I expect there to be a lip under here. Almost all audio equipment I've worked with has this type of design. Here are the screws in my magnetic screw holder. You can see that they stick together magnetically, so they're not pure copper, but maybe some sort of copper plating or copper alloy, who knows. I've learned the hard way that it's almost impossible to take these lids off with one hand. So, well, let's try it now. Oh, I was wrong. Okay, it's another impressive feature for Marantz. So, let's look inside. First thing you want to do when you pop one of these open is to look at all the large capacitors to make sure they're not swollen or burst. All the electrolytic capacitors, the small ones usually aren't an issue, but the bigger ones can be. So as a quick inspection, everything looks really good here as far as capacitors, no problems. Also, I noticed, I haven't seen this in other AV receivers, this appears to be copper plated chassis. So what's going on with that is kind of being very careful about keeping external noise out of the unit, electrical noise that is. Doesn't help with kitty noise. But everything looks really good here. We've got some dust. That's to be expected, no big deal. So let's take a tour of what's going on here. Here we've got the rear of the front panel. The most obvious thing here is this large knob, selector it says. We've got this large transformer. It's probably the biggest transformer I've ever seen in this type of AV unit. Got a copper strap around it. 2 large filtering capacitors, turn-on relay. This looks like a full-wave bridge rectifier here. Maybe probably not the primary thing. I'm guessing that's for the standby power supply. Oh, no, I'm wrong. This is the standby power supply over here. Our earlier tests showed that drew about 0.7 watts. So that's a pretty low power application to leave it running all the time. We've got what appears to be a choke around the electrical cord coming in. Here you can see the speaker connections on both sides down in here. Similarly, for some of the other connection boards, we can see both sides of it. This is a very typical type of design. You have a RF can that does most or maybe even all of the AM and FM receivers inside this can, where it's shielded in an RF sense. And then, these are some sort of computer controls probably that go into it on this ribbon cable, and maybe even delivers audio out, I'm not sure. This one says Cirrus Logic on it. They make a lot of A to D converters and D to A converters, so this may be kind of the main digital converter board of the unit. Here's another large IC that I don't know what that might be. We've got a lot of amplifier conditioning components on this side. I'm going to turn it around, we'll get a better view of the other side. But one thing I realized that these are probably power diodes creating what amounts to a bipolar AC supply coming out of this transformer. Topologically, we can see the AC going in here from this standby power board. It's kind of hard to see the path of the things coming out of the transformer. They appear to be here. We've got some more that go back towards the front panel to power that and maybe pass control back. We've got some more ribbon cables. Here you can see kind of a repeated topology. Let's count these large capacitors. 1, 2, 3, 4, 5, 6, 7. So that makes sense with a 7-channel unit. There's probably one section for each channel here, and the corresponding power transistors on the other side. So we'll turn it around and look at those next. Well, I guess the power transistors must be in place on the other side. This is just purely a passive heat sink. Very typical design. We've got vent on the bottom, convective cooling as the air rises through the thermal action and then goes out through corresponding veins in the lid that you see here. So there's probably 2 large power transistors per channel. Might look for those some more on the other side. But let's look at this area. There's another choke to keep RF noise at a minimum internally, electrical noise. Got probably some local 3-terminal regulators for local power supplies. Here's a crystal for what's undoubtedly the digital signal processing board that does the Dolby logic and things like that. There's more in here that I really can't quite see. Try to take a peek underneath here. It's kind of a difficult job with this board hanging over. There's an IC of some kind. So there's more processing back here. Maybe those are the Dolby processors or something, who knows. Lots of medium-sized electrolytics. So we've got some sort of audio going on behind there maybe. We'll peek in under here while we're at it. Nothing too exciting to see. Some these are called dip ICs. Those have kind of fallen out of use, but we're in kind of a transition period when this was made. The construction you see here of this board is typical of what you might see in this era around the early 2000s. We've got these are actually 74HC logic parts of some kind. We've got jumpers to work with a single-sided board. Same kind of thing here with the passive components and so on. Now here, this board in contrast is a surface mount board. Probably lots of layers, lots of pins, that kind of thing. So this has a mixture of construction techniques and the circuit board level, but that makes sense both for the era and also it's probably the most economical way to manufacture this type of unit is different techniques on different boards that kind of have different needs. Right, Scooter? Right, Scooter? Scooter's in an unusually quiet mood today. So while we've got this open, let's go ahead and blow out all the dust. Just for fun. I can't honestly tell you that makes it sound any better, but it seems like the thing to do. As you do this, probably the most important area to get is the heat sink. Although I don't ever plan to use a unit like this at full power where we need every bit of performance out of the heat sink, but why not? Okay, that's good enough for now. So as kind of a visual summary, I'm very impressed by this copper plated chassis. That's something I've never seen before. And you know, we've got more copper plated screws around here, like the ones I took out of the sides. So this is the kind of thing that you get when you pay more money for a high-end audio product, is this kind of really careful attention to detail in terms of you know, noise and electrical interference type of consideration. This shows a little pet peeve of mine, which is capacitors that aren't straight, but that really doesn't matter. They never are straight, actually. And don't straighten them because you might just break them off, but I just did. So there's a lot of really good stuff going on. Let's turn it again and try to find those power transistors. Well, upon turning this around again, I realized that the power transistors are undoubtedly connected directly to the heat sink. This board has a gap of perhaps a quarter inch or you know, centimeter, something like that, for those of you in the metric world. So we can't really see the power transistors without taking this apart, which I'm not going to do. But you can imagine there's probably two arrayed vertically for each of these 7 sections that I identified. So that's what's going on in the way of power transistors. I'm a little surprised at this kind of small bridge rectifier with what's probably you know, plus and minus DC voltage generated by diodes here. Maybe this is for a section of the unit that doesn't require very much power, but obviously the main power of the unit is going through this board, these bypass capacitors, probably one for the positive and one for the negative DC supply. And then we've got some smaller electrolytics kind of spread around the unit. And as I said before, those all look very good. Another thing you wouldn't typically get in cheaper units like this is this choke on the other one over here. You can see that's kind of a clip-on design, but that's more careful attention to detail. And that's, I'm not actually trying to sell you Marantz, but I'm just pointing out that you know, there is an aspect of you get what you pay for here. So that about wraps up this video. I'm going to do one more in the series where I do more of a listening test and evaluate some of the features. But any of you who are hoping to buy this type of unit, you know, a vintage Marantz in the AV receiver category, I'm really impressed with the construction here and think this would be a fine choice just from a sort of a visual engineering inspection point of view without having actually heard it, aside from a real minimal test that I did in the previous video. So that wraps it up. Thanks for watching, and bye-bye.